if you don't have graph paper and you have a printer, a lot of printers will be able to, like my printer, if I go into my options, I can actually print forms, and under the forms, there's a graph paper option. So I print graph paper on my printer. I mean, a lot of printers, I know HPs have been doing that for the last at least 15 years. But graph paper will be good today. Pen, pencil, definitely your calculator. Okay, so today is the start of the conics. Well, one of the conics being the circle. So again, we're doing circles, ellipses, hyperbolas, and parabolas. So we got 4 conics. Circles is definitely the easiest of the 4. Oh, what's my requirements say here? Complete the square. We don't need this quite yet. We'll need this tomorrow. I think tomorrow we'll need this. So guys, make sure you brush up on complete the square. I will go over it, but if you kind of review it prior to class, it'll make, it'll make everything feel better when we start doing it tomorrow. Okay, definitions. This is kind of just background information of what a circle is. So it's defined as the set of all points on a plane that are equidistant from a fixed point called the center. That makes sense. You have the center, and then we have equidistant from that point creates the circle. So it says the radius r of a circle is the distance from the center to any points on the circle. We all know this from taking geometry. This right here just shows a picture of a double-sided cone, and it takes a transverse slice to create a circle. We're gonna see this image again when we visit the other conics and how the slice is taken to generate not only a circle, but of course the ellipse, the parabola, and the hyperbola. Radius r. To this point here, we have x and y, and this is the Cartesian coordinate. And then your point is x comma y. Nothing new. Ooh, okay, now we get to the stuff. This is where your notes probably truly begin. So make sure you label this, and you might want to keep maybe a separate sheet of, definitely keep a separate sheet, because we're going to have formulas or the form of all your conics. And it'll be nice if you, in your notes, you kept a separate sheet that you're going to have all 4 equations on there so you can quickly kind of reference to. So this is the first one that we need to know. Now this is, you want to label this. This is the standard form of a circle. This is the equation in standard form of a circle. So we have the quantity x minus h squared plus the quantity y minus k squared equals your radius squared. And based on the diagram that you see, the center of your circle is h comma k. We have h is here in the formula, and then here is k. So h comma k is the center of your circle. That is imperative that you know this. And this is actually going to be true for circles and ellipses, at least. And actually parabolas and hyperbolas. Yeah, all of them. Yeah, h comma k. Just curious, have you done this in geometry before or in algebra 2? Okay. So you may have seen this. Okay, so standard form, of course, from the previous page. Center is h comma k, and the radius is r. So remember, the radius is r. So whatever number here, we have to convert it to some number squared. So if you see, well, let me try to explain with actual real example versus talking about it. But yeah, it is r squared. General form. So we have standard form and general form. We're going to have to convert between standard and general. I think we're just doing. I think we'll do that tomorrow. Yeah, we'll do the conversion of one to the other, vice versa, tomorrow's lesson. Today's we're just basically picking out the center and the radius, and maybe doing like a rough sketch on a graph. The general form, basically all we do is you foil this part out, you foil this part out, and then you move everything to the left side. So this is base. This is exactly what this is, just multiplied out and then put into order. X squared, y squared, x term, y term, and then your constant equals 0. So this is the general form. So on your test, tomorrow's lesson, it'll have questions about converting this equation from standard to general and general to standard. Make sure you have these written down. That way you know when I say standard or general, you know what I'm talking about. And if you don't remember it, you can just reference it on your paper. What happened to the radius? Are you talking about, oh, okay, good question. So question about what happened to the radius in the second equation. That is your radius. That's not in the general form. What happens is when you multiply this out, and you'll see tomorrow what I'm talking about, but you're going to get like a constant. You're going to get a constant in this foiling, and then you'll obviously have your constant here. And when you move it to the other side, you're going to combine like terms, and your radius value gets combined with the other constants and no longer becomes your radius. So that's why you don't have an r value in here, because there's no way to pick out your radius from general form. Good question. You guys are so smart. Okay, let's look at the first one. So based on what we looked at in the previous couple pages, and I give you, actually, let's do this one first. Let's do, I don't know. I feel like I need you to do me. Hold on, let me come back to these two. I feel like these are kind of tricks in a way, but not really. Let's do one like, let's do this one. One on the right on this page. We have x plus 2 quantity squared, and then we have y minus 3 quantity squared equals 9. All right, this one is super straightforward. All right, so think about this. Based on the standard form, what is the center coordinate? Go ahead and put it in chat. What do you think the center coordinate is? So we got so we got -2, 3. We have 2, -3. We got another -2, 3. So remember, let's go back to a couple pages ago. Look, this is a minus sign. So if that was a 5, it wouldn't be -5. H would just be a 5. So you can think of this as being the opposite. Let's going back to this one here. So whatever number is here, it's going to be the opposite. And I see, there's quite a few of you that did get it correct. But yeah, so remember, it should be in the form of x minus h and y minus k. So the h value is -2, and then the k value is +3. So that is the center. And the nice thing about these, you can go to Desmos and you can type that in and hit enter, and it'll graph a circle for you. And then the cool thing about that is you can pretty much eyeball this where the center is to confirm if your answer is correct or not. So as you're allowed to use Desmos on your quizzes, you're allowed to use Desmos on your exams, both parts. It is a tool to use. All right, what is the radius of this example? Wait, I didn't trick anybody. It is in fact 3. You are correct. You are correct. And we know because it should be r squared, right? So it's a 9. It's not 9 squared. It's not the radius being 9. It is r squared. So you have whatever number is at the, what it equals to, you have to square root it. And the square root of 9 gives you 3. And we know that 3 squared is 9. So that is your r value. That's your radius. So I didn't trick anybody in this class. Maybe I'll get some of you at the 10:30 class. But yeah, we want to make sure that you take this number, you square root it, because this is r squared. So that is your r value. Very good. And we can plot these. And we're going to have left 2, up 3, 1, 2, 3. I really hope all of you know how to graph. If you are super rusty at graphing coordinates, you need to watch a simple YouTube video on graphing coordinates. Pre-calc was a pretty tough class, and all this prior knowledge you really need to know. This one I consider very basic. And then we have a radius of 3. So from that point, now this is important, even though a lot of you are like, well, no kidding, that's how you graph a circle. We did this in geometry. I'm going to do it again. From that center, we want to go up 3, down 3, left 3, and right 3. So I'm going to do that. 1, 2, 3. 1, 2, 3. So there's 1 point. 1, 2, 3. There's another point. 1, 2, 3. Another one, 1, 2, 3. And assuming I know how to count boxes, that should be correct. And then once you have your 4 points, then we're going to actually graph the circle. Let's see. Wait, that is not a circle. Hold on. All right, well, let's try this again. All right, and there's my circle. There's my circle. And if we go to Desmos, we can type this in and we can verify this is correct. Pretty simple, right? Pretty simple. All right, let's go back to this page. Let me see how many examples I got. Okay, we got a few examples. Okay, so let's go to this one. I'm gonna give everybody, I think 30 seconds is definitely more than enough to do at least one of these. 30 seconds. All right, everyone, what is the center of the example on the right here? We're doing this one first. What is that center? 1 comma negative 2 is correct. Nice job. 1 negative 2. It's all coming back to us if we've done it before. 1 negative 2. All right, what is the radius of this circle? It is 1, and that's because the square root of 1 is still 1. I agree with you. All right. And graphing that just real fast. Got those, and then radius point, radius point. Hold on, let me zoom in a little bit. Okay, so good enough. Good enough. Not the best, but good enough. All right. Who is done with the first example on this page on the left? Anybody? Show me who's done. If you're not done, give me an X. I'll give you 30 seconds. All right, 30 seconds. Ready to go. All right, everyone. Let's do the easy one first. What is the radius of this circle? What is the radius? And we'll do the easy one. That's a 2. Yeah, definitely a 2 because the square root of 4 is definitely 2. So I'm going to put a 2 for the radius. All right, now the one that I'm hoping I trick some people. What is the center? We got a lot of 0, comma zeros. Nobody wants to say like 1, comma 1 or negative 1, comma negative 1. No one wants to say that. Wow. Okay. Well, all of you who responded are correct. It is 0, comma 0. So this problem right here, for whatever reason, it tricks people every year, and I think it tricks the ones that actually don't actually watch the recorded lessons or come to the live sessions, and the ones that probably don't practice a whole lot. This seems to get them every time, every year. It breaks my math heart. Why is it so? Someone wants to tell me on mic or in chat. Why is it 0, comma 0 for the center? Take the mic. No, it's all yours.
All right, so the answer is 0, comma 0 because in the standard form of a circle, x and y are both a number is subtracted from both x and y, but since there's no number that like x is that's subtracted from x or subtracted from y, that implies that it would be 0. So yeah.
Yes, Noah is correct. Because it's in a way it's this is simplified, right? Like on a TGA, on a test, never write your final answer. Like if I said, "Hey, what's the standard form of this?" and you stopped right here. This is not simplified. It may be in standard form, but it's not simplified. And x plus or minus 0 is still going to be x. And that's why it's x squared over here. Now, if you want to write this to kind of just see it and say, okay, now I can actually see h and I can see k. And h and k are both 0. And that's why the center is 0, comma 0, basically what Noah said. So don't let this trick you. Whenever you see x squared, the h value is 0. And whenever you see y squared, the k value is 0. This gets people every single time, and you will definitely see it on your quiz, your test, and possibly your TGA. I don't remember. So center 0, 0. Good job, everyone who got that correct. Right. So there's your center. Up 2, down 2, to the right 2, and to the left 2. And then we do our circle. I'm going to get my circle tool out. All right, good enough. Good enough. All right, how's everyone feeling about standard form and pulling out center and radius of a circle? Pretty excellent, right? Pretty excellent. Nice. All right, let's, we got 2 more examples. Wait, 2 more examples? 3 more examples. We have this one on this page, and then we have these 2. So let's, everyone go ahead and do this one here. And I'm going to give you 30 seconds to do that. Ready, go. All right. All right. Is everyone finished with this problem? For those that are not finished, how much time do you think you need? Okay. All right, we'll start with the easy one. What is the center of this circle? All right, 1, 2. I think we got that one down. All right, everyone. What is the radius? Ooh, everyone got it right. Nobody put a decimal. That's because we all know decimals are bad, right? And that your answer should always be in fraction, or in this case, radical form. So yeah, very, very good. 2 radical 3 is correct. 2 rad 3. That looks like a 5. Hang on. Now, the problem with radicals or even fractions, sometimes when we look at them, we actually don't know what the approximate value is. Like when I look at 2 radical 3, like I have an idea of, I know it's less than 10 and I know it's more than 2, but that's really about as far as my brain can handle. So to graph these, if you're doing them by hand and not using Desmos, we do have to convert it to decimal just so we know the distance from the center. So approximately, round to the nearest hundredths, what is the decimal of 2 radical 3? Hundredths. That's tenths. I want hundredths. Tenths, 1 decimal place. Hundredths, 2 decimal places. Yeah, so it's about 3.46. Yeah, 3.46. But like Rachel says, about around 3.5, a little less than 3.5. So I'm going to go up and down just slightly less than 3.5. So we're going to go 1, 2, 3, and maybe a little less, something like that. 1, 2, 3. Wait, hold on. It's 2.5. I can't count, guys. 1, 2, 3. Or maybe I did do that right. 1, 2. No, I did it right the first time. 1, 2, 3, a little less than a half. 1, 2, 3, a little less than a half. 1, 2, 3, a little less than a half. All right. Hopefully, so that's roughly 2 radical 3 distant from the center. Then we get our and something like that, right? Not too bad, right? Not too bad. All right, last 2 examples of the day, and then we'll call it. All right, so I'm gonna give you all. We'll do 4 minutes. I think 4 is definitely plenty. And then after 4 minutes, I'll take 2 volunteers to write the answers for us and also graph it for us. And by the looks at it, the second one on this page is just more of a pain to graph than the one on the left. 4 minutes, ready, go. All right. Is there a volunteer for the first one to write down your answer and to graph it for us? All right, then Noah can do the first one. What about the second one, the harder one? We got 9 of you in this class. One of you've already volunteered. Remember, you can use the text tool. There's a tool to actually type to put your answer if you don't want to write with your mouse. And then there's also a tool to, well, obviously to write, to draw points, and to do your circle. So, all right, Rachel, please do number 2 on this page. Well, thank you for recognizing I was talking and you couldn't hear me. So what I was saying was, here's something cool about Neuro. When drawing this circle, if you hold down Shift while drawing the circle, it'll draw the circle starting from the center and expand outwards versus what it does normally, if that makes sense. All right, Rachel, we just need the center and radius. All right. Who agrees with both of these answers? In other words, who got the same answer? Right. Looks like some of you haven't responded. But if you don't agree, any comments you want to add about these answers? No comments? Yeah, they look pretty good to me. Um, Actually, they don't look good to me. Yeah, there's actually a really big problem here. So one person disagrees, and I actually see why. Hmm. Hmm. Yeah, and there's actually a pretty big problem with this graph on one of them. Oh, Rachel, you see it. You see it, don't you? And I'm guessing the 7 people that gave me smiley faces that they agree, they did not graph their answers. You just did the center and radius, and you just went ahead and you foregoed the graphing parts. Shame on all of you. Yeah, this stuff is correct. The graph is not correct. So I think you're able to drag your stuff if you want to move it, Rachel. It's okay to mess up. I don't know if I can drag. Can I drag? Oh, I can drag. Yeah, look at that. I can. All right, go ahead and move those points where they belong. All right. Well, let's look at it. The center is -3, 3. So let's graph the center again. Where should we go for the center? So Rachel, did you graph this before writing down the center and radius? Oh, you didn't? Okay, so you did write it down, you just flip-flopped. That's all right. Well, at least you're honest. All right, so -3, 3. Where should this go? There we go. Yeah. Left 3 and up 3. So -3 in the x direction, +3 in the y direction. It's all right, Rachel. 7 other people missed this problem too because they agreed with the answer. So you weren't alone. There's only one person that disagreed. And it wasn't me, by the way. I looked at it and I thought it was fine, just like everyone else. Yep, yep. All right, good enough. Okay, now the question is, do we agree with the answer? All right, good, good, good. Yeah, it's easy to do that, especially when the numbers are the same. It's easy to do that. It's also easy to look at an answer and say, "Oh, that looks right" on quick glance. Oh yeah. Yep. Don't apologize. All right, everyone. Um, well, I think that's it for the day. I want to say it before I stop the recording. We will not have live class next week on Tuesday or Wednesday, but I really don't like not having either recorder or a live lesson for, well, everything. So I'm thinking about doing is tomorrow. So Friday we'll have the regular lesson, and then in the afternoon, maybe around noon, I will probably have another lesson on. It's probably will be day 3 of. Hold on. I need to think about what I'm going to do because I need to fit in 2 lessons. So whatever I'm going to do, I'm going to have one lesson tomorrow afternoon, and then on Monday we're going to have another lesson in the afternoon as well. But the order is going to be really weird. So if you come to class on Monday without watching the recording on Friday afternoon lesson, you're going to be lost. So keep that in mind. So you can, I guess you can consider watching that, doing that lesson as homework for the weekend, because come Monday, if you don't view that, you're going to be lost. Okay, just want to say that. All right, guys, thanks for coming. And as always, I hope you learned something. I will see you all tomorrow.